Yes, in the last class we discussed about the chemical equilibrium, that is the Kc derivation, that is the equilibrium constant in terms of molar concentration of the reactant. Suppose in case of the gaseous reactions, we are expressing the concentration in terms of the partial pressures, then how do you obtain the equilibrium constant value? Equilibrium constant for gaseous systems, equilibrium constant for gaseous system. It is obtained by Kp values. Equilibrium constant for gaseous system, that is in terms of Kp values. Equilibrium constant in terms of partial pressure. Let us consider a chemical reaction. Let us consider a chemical reaction. AA plus BP equilibrium with CC plus DD. For Kc, that you know, that is C to the power of C into D to the power of D divided by A to the power of A into B to the power of B. This is for Kc expression. But for Kp expression, that is the partial pressure of C to the power of C into partial pressure of D to the power of D divided by partial pressure of A to the power of A into partial pressure of B to the power of B. Partial pressure of B to the power of B. Now see, we know that PV is equal to nRT. PV is equal to nRT. That is from kinetic gas equation. Therefore, P is equal to N divided by V into RT. What do you mean by N? N is the concentration factor. N by V is equal to concentration. That is equal to molar concentration. N by V is equal to molar concentration. N by V is equal to molar concentration. Because N is equal to number of moles, V is equal to the volume of the solution. Therefore, N by V is equal to molar concentration of the solution. Since N is equal to number of moles, N is equal to number of moles, V is equal to volume of the solution. V is equal to volume of the solution or volume of the container. Therefore, this is P is equal to suppose PA is equal to molar concentration of A into RT. PB is equal to molar concentration of B into RT, and C is equal to PC. PC is equal to molar concentration of C into RT. PD is equal to molar concentration of D into RT. Molar concentration of D into RT. Now substitute the values in Kp. Substitute the values of Kp. Substitute the values of Kp. Kp is equal to Pc to the power of C into Pd to the power of D divided by PA to the power of A into PB to the power of B. Substitute the values of PA. PA, PB, PC and PD. PC and PD. Now KP is given by PC, C to the power of C into RT, that is a PC, that's whole to the power of C, into, there is a D into RT whole to the power of T divided by A into RT, that is a whole to the power of A, B into RT, that whole to the power of B. Now this is given by, Kp is given by, that is C to the power of C, that is C to the power of C into RT to the power of C into D to the power of D into RT to the power of D, RT to the power of D, whole divided by A to the power of A to the power of A into RT to the power of A into B to the power of B into RT to the power of B. Now it is equal to concentration of C to the power of C into D to the power of D divided by concentration of A to the power of A into concentration of B to the power of B, that is equal to RT to the power of C plus D divided by RT to the power of A plus B. Now you know that this is equal to Kc. This is equal to Kc. Therefore, Kp is equal to Kc into RT to the power of C plus D minus A plus B. C plus D minus A plus B. That is given by Kp is equal to Kc into RT to the power of delta N. RT to the power of delta N. What do you mean by delta N? Delta N is equal to number of moles of the gaseous products minus number of moles of the gaseous reactants. Number of moles of gaseous products, number of moles of gaseous products minus number of moles of gaseous reactants. Number of moles of gaseous products minus number of moles of gaseous reactants. This is the derivation between that of the Kp and Kc. Where is the Kp in terms of the partial pressures for gaseous chemical reactions, whereas Kc is in terms of molar, that is the equilibrium constant in terms of molar concentration of both the reactants and products. In the reaction A plus B equilibrium with, this is problem. In the reaction A plus B equilibrium with C plus D, comma, the initial concentration of A and B were 0.8 mole per liter each. At equilibrium, the concentration of C was found to be at equilibrium concentration of C was found to be 0.8 mole per liter. Mole per liter. Calculate the value of equilibrium constant. Calculate the value of equilibrium constant. So this is 0.6. This is 0.6 moles per liter. Solution. For the reaction A plus B equilibrium with C plus D, Kc is given by molar concentration of C into molar concentration of D divided by molar concentration of A into molar concentration of B. Initial concentration in terms of moles per liter. Initial concentration in moles per liter. Initial concentration in moles per liter. A is 0.8, B is also 0.8. Initial concentration of C was found to be 0. This is 0.0, this is 0.0. This is equilibrium concentration. Equilibrium concentration of this A is 0.8 initial and 0.6 is consumed. This is in terms of moles per liter. This is also 0.8 initial and 0.6 is consumed. This is initially 0.0 plus 0.6 is formed. This is initially 0.0 and 0.6 is formed. Therefore, it is found to be 0.2 moles per liter. 0.2 moles per liter. This is also 0.2 moles per liter. This is 0.6 moles per liter. This is 0.6 moles per liter. 0.6 moles per liter. Now substitute the values of this one. This is 0.6 into 0.6. This is 0.2 into 0.2. That is equal to, this 1s are, this is 3s are, this is 1s are, this is 3s are, this is 9. Therefore Kc is equal to 9. Kc is equal to 9 for the reaction. Kc is equal to 9 for the reaction. Let the equation N2 plus O2 equilibrium with 2NO. Equilibrium with 2NO. Initial amount. Initial amount. Here 2 moles of nitrogen. Initial amount in moles. Initial amount in moles. 2 moles. And 3 moles of oxygen. Initial amount of nitric oxide is 0 moles. Initial amount of nitric oxide. At equilibrium, equilibrium amount. Equilibrium amount. Equilibrium amount. They mentioned at equilibrium usually contains 1 mole of unreacted nitrogen. 1 mole of unreacted nitrogen. Unreacted nitrogen means 1 mole used up and 1 mole unreacted. 1 mole of unreacted nitrogen. This implies that 2 minus 1, 1 mole of unreacted nitrogen is 1 mole left. 1 mole left. For every 2 moles of, according to the stoichiometry, 1 mole of nitrogen would react with 1 mole of oxygen, then it gives rise to 2 moles of the nitric oxide. Therefore, initial amount of nitrogen, that is 2 moles, 1 mole left means 1 mole used up. Here oxygen also there. For every 1 mole of nitrogen, 1 mole of oxygen would react. Therefore, 2 moles that left under equilibrium. 2 moles that left under equilibrium. Then the amount of the nitric oxide formed, that is 2 mole, because 1 mole plus 1 mole, that is equal to 2 moles of the nitric oxide is formed. 2 moles of the nitric oxide is formed. One mole used up, 1 mole used up and 1 mole left. Here 1 mole used up, 2 moles left, and 2 moles formed. Okay, this is 1 mole left, here 2 moles left, 2 moles formed, and then 0 plus 2 moles. 0 plus 2 moles. 0 plus 2 moles are formed. Then how do you give this Kp expression? Sir, Kc expression. Kc expression for Kc expression. Kc expression for N2 plus O2, that equilibrium with 2NO is Kc is equal to molar concentration of nitric oxide whole square divided by molar concentration of nitrogen into molar concentration of oxygen. Whereas concentration of nitric oxide, that is equal to 2 divided by V, that is a moles per liter. Concentration of nitrogen, that is 1 divided by V moles per liter. Similarly, concentration of oxygen, molar concentration of oxygen, that is 2 divided by V moles per liter. That is the left amount. Now substitute the values. It is 2 by V whole square. This is N2 is equal to 1 by V. O2 is equal to 2 by V. Now substitute the values. It is a 4 divided by V square whole divided by 2 divided by V square. That is equal to how much? V square get cancelled. That is equal to 2. Therefore, Kc value is equal to 2. Kc value is found to be 2. Therefore, Kc is equal to 2. Kc is equal to 2. When does Kp and Kc are? We know that Kp is equal to Kc into RT to the power of delta n. RT to the power of delta n. When delta n is equal to 0, then Kp is equal to Kc into RT to the power of 0. Then Kp is equal to Kc into 1, Kc into 1. That is equal to Kp and Kc both are equal. Kp and Kc both are equal. Kp and Kc both are equal. Now, delta n is equal to 0 means number of moles of gaseous products, number of moles of gaseous products, number of moles of gaseous products is equal to number of moles of gaseous reactants, number of moles of gaseous reactants. That is C plus D is equal to A plus B. C plus D is equal to A plus B. Example, in 2HI in gaseous state, equilibrium with H2 in gaseous state plus I2 in gaseous state. Here compare the coefficients. It is balanced chemical equation. It is balanced chemical equation. It is balanced chemical equation. Number of moles of reactant. Number of moles of reactants gaseous in nature. Number of moles of reactants in gaseous form, that is equal to 2 mole. Number of moles of products. Which type of the products? Gaseous products, that is equal to 2 moles, and hence delta n is equal to number of moles of gaseous products, number of moles of gaseous products minus number of moles of gaseous reactants, number of moles of gaseous reactants, that is equal to 2 minus 2 is equal to 0. 2 minus 2 is equal to 0, and hence Kp is equal to Kc. Kp is equal to Kc. For the expression 2Hi equilibrium with H2 plus I2, Kp and Kc both are equal. Kp and Kc both are equal. Whereas N2 plus O2 gives rise to example number 2. N2 plus O2 equilibrium with 2NO. All are gaseous in nature. Equation is balanced. It is balanced chemical equation. First, that should be balanced. It's balanced chemical equation. If it is not balanced, you have to balance. Calculate number of moles of gaseous products. Number of moles of gaseous products. It is equal to 2 moles. Number of moles of gaseous reactants. Number of moles of gaseous reactants, that is also equal to 1 plus 1, that is equal to 2 moles. Therefore delta n is equal to how much? Number of moles of gaseous products, number of moles of gaseous products, number of moles of gaseous products minus number of moles of gaseous reactants. Moles of gaseous reactants, that is equal to 2 minus 2. That is equal to 2 minus 2, 0. Therefore, Kp is equal to Kc into RT to the power of delta n becomes Kp is equal to Kc into 1. That is Kp is equal to Kc. Kp is equal to Kc. Okay. Thank you. These two examples in which the Kp and Kc values are equal. You can take so many examples from your NCERT textbooks where the number of moles of the gaseous reactants and number of moles of the gaseous products are equal. Thank you.